Hello, our objective today is that you are going to graph rational functions based on their key features. And in this case, their key features means two things, the zeros and the vertical asymptotes. So zeros occur when the function equals 0, and that always occurs when the numerator equals 0. So if this equals 0, then you get zeros. And vertical asymptotes occur when there's an x value that is not in the domain because you can't divide by 0. So in this case, if the denominator equals 0, then you get vertical asymptotes. So our two key features here, one comes from the numerator and one comes from the denominator. Both of these are kind of based on the zero product property, but I'm going to do these a little bit more straightforward. X plus 4 equals 0 when x equals negative 4. There's no other way to say this. I could show the work for this if I wanted to, but I just want to keep in mind that what we're just looking for is the value of x that makes this 0. Negative 4 plus 4 is 0. And for the vertical asymptotes, what value of x makes x minus 3 0? Well, that's positive 3. So we have a 0 and x-intercept. I'm going to put a dot at negative 4 right there. And then we have a vertical asymptote at 3. And we draw vertical asymptotes by drawing a vertical dotted line at that x value. So remember, an asymptote, vertical or horizontal, is kind of a fence. It's a line that our graph does not touch or cross, even though it usually gets close to it. These are our key features, and we're now going to use the excuse me. We're now going to use the graphing calculator to see exactly what that looks like. So I'm looking at my graphing calculator. I've already got this function typed in. I'm going to hit graph, and what I see is a line that goes through that 0 right there, hits the vertical asymptote. You can kind of see where there's a gap right here, and then re-emerges on the other side. And this is a function that is not continuous. This side right here goes down to negative infinity, and then up here it goes up to positive infinity. And rational functions just look like that. So let me start that over. We're gonna have a line that goes through that 0. It's the only 0 that goes down, down, down toward negative infinity as it approaches that asymptote. And then on the other side of that asymptote, it comes down from positive infinity, and it kind of looked like that. Again, I'm just kind of drawing what this looks like. Just as a reminder, we only found 1 0, so that's the only possible one. So over here on the right side, I wasn't getting close to it or anything like that because I knew there wouldn't be another. All right, next example. We're going to do the same thing. So zeros occur when the numerator equals 0. In this case, that would occur when x equals 5. That means that only once is this function actually going to touch the x-axis, and it's right there. And vertical asymptotes occur when the denominator equals 0. So that occurs at x equals 0. That's the only value that would make this come out to 0. So we're going to have a vertical asymptote right at x equals 0, which is just also the y-axis. And now I'm going to go back to the graphing calculator. I'm going to go to y equals, and I've already got this typed in, but I need to turn off the other function. So I'm going to turn on this function and then turn off the other one. Go to graph. And all right, well, we see it. So we see a line that is in the positive space on the left side, and then mostly the negative space until it hits that 0, and then it continues on the right side. So I'm going to sketch in that graph. It's in the positive space on the left and negative space on the right until it hits that 0 and then comes up above. Remember, these lines approach but don't touch the asymptotes. You're just sketching it in, so I'm not expecting it to be perfect, but that's generally what it should look like. So our objective today was that we graphed rational functions, meaning that they're written in algebraic terms as a fraction based on their key features, which were the zeros and the vertical asymptotes.